On these next 2 pages of notes, we're going to address the centripetal versus centrifugal accelerations that are talked about for circular motion. Now, both are valid words, valid descriptions of effects that occur for circular motion. However, for our problem solving, for this course, for us, please make sure that you get in this yes versus no. We will only ever use centripetal. Centra, meaning towards the center of the circle, from the Latin centrum. Petal, from the Latin pito, and that's to seek or to strive after, to seek the center. Centrifugal is an outward acceleration, outward force that you would feel if you're inside of an object moving in a circle. And we're going to talk about that at the bottom of this page of notes. So for us, we are going to be laser focused on A radial. Some textbooks will actually use A sub C instead of A radial. I explicitly use A sub rad. That acceleration will always be radially inward. It is impossible to have circular motion without this acceleration, because you do not have circular motion without motion v, and you do not have circle without a radius r. Now, what is this centrifugal? Well, as it says here, centrifugal refers to this non-inertial, and I'll explain what I mean by non-inertial in a moment, but centrifugal refers to this non-inertial acceleration. We will never use it whenever we use Newton's laws of motion, which we will always use to do our measurements. However, as it says here, when you are inside of an object moving in a circle, you do actually, in reality, feel as if there's an acceleration v squared on r radially outward. So for example, our turtle here inside this blue box, we are going to be the inertial, not moving, so inert. Not moving. This is us. This is our Newton's reference frame. Newton realized when he structured his mathematics to describe how the world works that his description of the world was predicated on the existence of this at-rest reference frame, that the accelerated reference frame, which is the box in this case, the blue box is accelerating v squared on r, right, radially inward. The box is being held in the circle, in this example, by a rope. So when we do our next chapter 5, we'll see forces cause accelerations. There's a force on the box by the rope radially inward, keeping this blue box moving in a circle, as the blue box, of course, wants to move off tangentially. So you have the inclination of the box to move off in a tangential sense, and the rope pulls it back in, keeping it in the circle. Now, for an object like the turtle in the box, as it says here, the turtle is in an accelerated reference frame because the box is accelerating v squared on r radially inward. When you are in an accelerated object, like a car, accelerating forward, you feel yourself pushed to the back of the seat. When you're in this accelerated box, the turtle would feel as if it's being pushed to the outer wall, but as it says here, and please get these into your notes, these two forces, the force on the turtle by the wall and then the force on the box by the rope, radially inward, because we are always going to note we never put a net radially outward force in a circular motion problem. It cannot exist. The only force that can exist, net force, is a radially inward one. And we'll do a lot more with this in chapter 5, so we don't need to go into detail with forces. So the bottom line for us is that centripetal, yes. Centrifugal, no. Radially inward, yes. V squared on r. So we have one more page of notes about this centrifugal to talk about, and that would be this situation. I have centrifugal confusion because when you're spinning in a circle, so here I have just two bubble people, so they're just heads, and again, we'll pretend they're attached, their heads are attached to ropes. And we'll say our inertial observer, our snail, is out here. So at rest relative to the center of the circle, watching these two objects go around. So if we had an observer, observer 2 here, ahead of observer 1, and what we're looking at is the case where what if, right as object 1, person 1, gets to this point, the V tan, right, is in this direction, the string breaks. Well, if the string breaks right at this point, the person themselves would think that this is going to happen. So the person would think, oh, I've got this outward force pulling me outward, I'm going to fly outward. Person 2, on the other hand, if they're observing person 1, would see this type of behavior, not because the person 1 is actually swooping out in this direction. This does not actually happen. What actually happens is that the person flies off tangentially, but person 2, as they move away, right, from this red line, would perceive the green that the red person is flying off to the right as well. So this is often a multiple choice type question, concept type question for centrifugal versus centripetal acceleration and motion based on the inertial observer. So please get this into your notes. We, of course, can talk more about these concepts in class. Our problem solving, as I said, will never involve centrifugal acceleration, and we really won't even talk about it past this point in the course.